Um, I'm Ramprasad. I am a bioinformatician at Clinical Genomics in Stockholm. And I work in a team that works closely with the local hospitals to try and develop pipelines for diagnostic needs. This might actually seem like somewhat of an innocent statement to make, but there is a big problem in what I just said. The problem is one of fragmentation, right? Often like hospitals work with units that are sort of work closely with specific units, and you have this happening at different places, which means that people just start to work in silos, right? So for example, if you look at Sweden, so in Sweden we have 21 regions, and these 21 regions are responsible for their own healthcare, and being responsible for their own healthcare means they establish the same units at multiple different places doing the same thing, and over time, people just start to sort of reinvent the wheel, do their own thing, and that leads to a situation where there is like very little knowledge transfer between the groups, and they also, especially if you look at computational biology side of the healthcare, people often just end up writing pipelines that are very specific to their local needs, and but with the same aim. So, for example, if you can have multiple units working on rare disease diagnostics, but then you end up in a situation where you just have multiple pipelines all doing the same thing, but very specific to the local infrastructure. So this means portability also becomes an issue. So it's just hard to find people to collaborate with. So this is, in Sweden, we realized that this was an issue. So different hospitals and regions sort of came together to start Genomic Medicine Sweden, which is sort of an initiative between several partnering regions and the hospitals. And it was and the goal is to sort of bring genomic, bring genomic diagnosis into clinical practice. Under this GMS organization, we have 7 different participating units, as you can see in the map here, and I sit at the GMC Karolinska. One of the goals of GMS is to sort of establish national standard pipelines for different disease groups. So, for example, we want to establish one pipeline for rare disease diagnostics, one for cancer, and one for metagenomics and things like that. If you're starting to sort of think about making something that can be established as a national standard, it has to be something that's easy to collaborate with, because different units have to be able to contribute to it. And to sort of to help them collaborate, you need the pipeline to be sort of agnostic to the computing infrastructure that it is being run on. So of course, we decided to sort of, develop the pipeline in C. No. Just kidding. So of course, we ended up doing it with Nextflow, and one of the benefits of us choosing Nextflow over other workflow managers is the support from NF Core community. The initial days, of course, I sit in Stockholm, where Phil, Maxime, and several other Nextflow or NF Core co-group sits. So we've had several discussions, and in the end, we decided to sort of start developing a Nextflow. So that's kind of how NF Core Rare Disease began. And if you're starting to develop a pipeline and trying to work with multiple groups, you need to start somewhere. So we decided to use a pipeline that we are running in production in Stockholm region to diagnose patients as a template. And the plan was to add features that were different but were being used by other units on top of the template, and sort of build something that incorporated things that all the units were doing, and sort of like keep it very customizable so different units can choose, how they want to run this pipeline. So if you guys want to know more about the template pipeline that we use, you can find it at this GitHub repo, and there's also a paper that was published 2 years ago, which should help you, in case if you want to know more about the pipeline. So it's been a 2-year journey, and this is what the pipeline looks like today. I mean, yeah, we've seen several iterations of like metro maps for different pipelines, so you guys are very familiar with how this, how to read this image. So the pipeline, so the way we sort of like thought about this pipeline is to sort of have, sort of different units that you would typically see in a rare disease pipeline. And sort of keep it in a very sort of a customizable way. So for example, of course, it's very typical to do a pre-processing and you do the alignment. And in alignment, we had this challenge because we had one unit that was using Cention and we were using BWA. So then we sort of like kept it at customizable so people can run Cention if they have the license to run it. And then, of course, Cention also has a variant caller, which the other units were using, but we were using deep variant, so we needed to be able to sort of incorporate that difference. So we added that feature as well. But the way we have sort of written this pipeline, if at some point the unit that's running deep variant wants to run Cention as an aligner, they can still do that. So they can use a Cention as an aligner and run deep variant. So we've tried to sort of keep the pipeline very modular. And the pipeline also has several other features. So of course I mentioned pre-processing, alignment, and variant calling. So there is also a structural variant calling, and we have CNV callers. We also have a separate mitochondrial workflow, which, because, of course, it's somewhat different because you typically have very high read depth, so we had to have something separate that sort of accounted for those differences, so we incorporated GATK's mitochondrial sub-workflow. It's one thing to get all the variants, but then you also need to be able to annotate it. So we also have several annotation workflow that annotates SNVs, SVs, mitochondrial variants, and of course you also need you get QC metrics as well from the pipeline. Right. And at the moment, the pipeline can handle whole genome sequencing data, whole exome sequencing data, and the whole exome sequencing data. It should also work with panels. We haven't tested it, but I mean, there is nothing in the pipeline that shouldn't or that doesn't support the panel data. So it should work with panel data as well. And because this is a rare disease pipeline, you also need to be able to sort of handle, like families with different dynamics. So trios, single sample, and whatnot. So, and the pipeline is written in a way that it should be able to handle it. I invite you also to sort of like test and see if you can break it. And if you can break it, please let us know and we'll try and fix it. Because that shouldn't be happening. So what is in the future? The plan is to add several more features. So we lack mobile element insertion and corresponding annotation at the moment. So we want to add that. We also want to add some support for Dragon, and there was some progress during the hackathon on this front. I think we have a sort of a base Dragon module, and then of course modules repository in a PR. And the future is in long reads. So we also want to be able to support long reads at some point. And of course, like we want to be able to, as you saw, I mean, there are several parts to this pipeline, and it would be great if we can sort of like bring enough tests to sort of customize and like test and be able to test the pipeline as we develop it. And one feature that we don't have, but we would like to have is multiple entry points, which Frederica was talking about for SAREC. So we want to be able to do the same thing with rare disease. So people can, sort of choose what parts of the pipeline they want to run and just be able to run that specific part. And we also want to be able to optimize it. At the moment, we only do scatter gathering at the annotation stage. We want to be able to see how useful it can be during annotation and other stages of the pipeline. So that's kind of where the future is for the rare disease pipeline, I see. And that was more about the pipeline, but since this being an Nextflow Summit, I also wanted to sort of talk about a feature that I really like about Nextflow. Like most of you guys will be able to sort of understand like what's going on in that slide, right? I mean, it's just a sort of simple retry strategy where if a process fails because of certain error codes, then try it again with like more memory or more CPU. And the reason I like this feature, and other developers in my team like this feature, is that we work with hospitals, and we also work for a university, which means we have to be very conservative about like the costs. So we can't go crazy about with our computing infrastructure, but at the same time we have to be able to reduce the turnaround times for the samples so that we are able to get the reports to physicians as soon as possible. And often, like, we would run into situations where a process fails because because there was not enough memory, or like not enough maybe it went over the time limits on the cluster or whatever. The issue we've had, or we still continue to have because it's not in production, is that in production, like pipelines would start analyzing a sample, and they would sort of fail because there is not enough memory, and then someone will have to like go in manually and fix it, or like start a rerun with more memory to sort of run to get the sample to run to completion. This is a big problem for us because, if you have a sample that fails on a Friday, no one, you kind of have to like wait until someone comes in on Monday and restart it, which means that we've sort of like lost 2 days in the process. And this also means that we have resources that are just like doing things manually, which we could otherwise automate. So we are very excited to sort of like have this feature in production, because this would mean like our production team will be spending less time doing this and more time maybe like working on other features that could be useful to have in the production. And for patients, of course, this means they get a diagnosis faster than they otherwise would. So one of my colleagues, Jesper, recently said that teamwork is dream work, and in that spirit, I would like to thank all the people that have contributed to the pipeline, and and also the NF Core community. They've been very, very helpful in the past 2 years, especially like people like Maxime, who was willing to sit down and like have several meetings with me, and like he let me pick his brain. Thanks to all those people, and sorry, I don't know, there was, and also I would like to thank GMS and SciLifeLab for supporting this. Yeah, that's it.
Thank you so much. Great talk. There's again a number of questions in Slack. We're out of time to ask them to you right now, but a lot around the flexibility and versatility of the pipeline. I think there's a lot of interest. Thank you.